All right, hello, welcome back. Today we are covering section 12.1, part 2 in geometry with our trig ratios. So in our last lesson, we talked about SOHCAHTOA and how to set it up on a right triangle to find a missing side length. Today we are going to be doing kind of the opposite. Instead of a missing side length, we're going to be looking for a missing angle. So here, when we are given two sides of a right triangle, you can find the measurements of the missing angle by using trigonometry. This is called inverse trigonometric functions because you are undoing the trig steps to solve for the missing angle. So this is going to look a little bit different, and it's going to be a slightly different button than what we used before, but we can set it up the exact same way. So the inverse sine is when we have sine with this little -1. And again, it's just a button on our calculator. Inverse cosine and inverse tangent. And I'll show you what those are on our calculator in a moment. But again, you're going to set it up completely the same as we did in the last lesson. Figuring out sine or opposite, adjacent, or hypotenuse sides. Is that sine, cosine, or tangent? And then we're just going to do a t-chart. And with that t-chart, we're going to get rid of the sine, cosine, or tangent function, just like we would get rid of a multiply with a divide or an add with a subtract. My dogs are going crazy, so I'm not sure if you can hear that in the background. All right, example 1 here. I can see that I've got this side length, which from the given angle, which is now listed as theta, I can see that that side is the opposite side. And then we also have, let me choose a different color here. We also have this side length, and that length is between the theta angle and the 90 degrees, so that would be adjacent. So with SOHCAHTOA, I can see with O and A, we're going to be picking the TOA part, which means the tangent function. So I'm going to say tangent, and then next to that always goes our angle measurement, which in this case is theta. And then opposite comes first, so that's going to be on the top, 26, over the adjacent comes next, which is the number 45. So here you can see already that this is different because the variable, the missing part, is not in the ratio itself. So when this happens, we actually don't have to create a proportion. We can just jump right to a t-chart. Now, for some of you, depending on your calculator, you might not want to have the fraction 26 over 45, but it could come out to a yucky decimal, and we don't want to round until the very end. So just make sure that you use the parentheses appropriately when you type this into your calculator. All right, we're going to do a t-chart. Now this time we're actually trying to get theta alone. So tangent is not being multiplied to theta, it's not being divided or added or subtracted, it's being applied to theta. And we have to unapply it to theta, which means we have to do the inverse of tangent, which is written like this. So just like a t-chart, I'm going to do it to both sides. Now this tan inverse is going to cancel the tangent, and then our theta is going to drop down. Now over here, this is where it's going to look a little different on your calculator. We can't just have the fraction in there and then apply the inverse tangent unless you have an iPhone calculator or something like that. But what we're going to write it out as tangent inverse of 26 over 45. Okay, now when I type this into my calculator, I'm going to type it in as tangent inverse 26 divide 45. But I need to make sure that I have that in parentheses. And I'll jump over to my calculator to show you how that looks. Let's see here, calculator. Okay, on my calculator, let's see here, maybe I can keep these both up at the same time. Fantastic. So I'm going to type in, let me clear this out, the inverse tangent. So tangent, the button, right above it, I can see tan -1, the inverse. So I'm going to hit the second button on the left. I can see that the arrow has pointed up, showing me that it's in the second mode, looking for the values that are above the buttons. And then I'm going to hit tan inverse or tangent button. And I can see it comes up with that little -1 for me right away. It's already got the parenthesis to start, so then I'm going to do 26 divided by 45, close my parenthesis, and hit equals. Now, again, if you got something different, it simply means that you might be in the wrong mode on your calculator. So double check that with your teacher. All right, now, because these are angle measurements, typically we don't do angles in decimal format. We just say to the nearest whole number. So I'm going to round this to about 30 degrees for our inverse tangent of 26 over 45. So that means this angle right here is approximately a 30-degree angle. Now, being that we already have the 90-degree angle, then I could say, oh, this one up here would have to be 60 because 30 plus 90 plus 60 makes 180 degrees total. All right, let's try example 2. Just choose this guy to make him bigger. Let's see here. It's not liking me. There we go. There we go. All right, example 2 then. So on example 2, I have this measurement over here given. Now that is all the way on the opposite side from the angle theta. And then we have this measurement given, which is 105, and that is across from the 90, making it the hypotenuse. So with O and H, this would be the SO abbreviation, which means the sine function. Next to that's going to go my angle theta, and then my sine function, or the abbreviation SO, I'll write it down up here, SOHCAHTOA. And the abbreviation SO, I can see that the O value comes first, so that would be our 48 divided by the H value comes next, which is the 105. And then I'm just going to do a T-chart. I'm going to inverse sine on both sides. That will cancel out my sines. My theta drops down. And then when I type this into my calculator, I'm going to type in the inverse sine of 48 divided by 105. All right, jump to my calculator. Inverse sine 48 divided by 105. And again, I'm going to round to the nearest whole value for angles. That would be about 27 degrees. So this angle that was missing right here is approximately a 27-degree angle. All right, let's try the next one. Example 3, I have a measurement down here. I can see that's between the 90 and the given theta angle, so that would be the adjacent side. I have a length over here, which is across from the 90-degree angle, so that's the hypotenuse. So with SOHCAHTOA, we can see that this is going to be the ka, or the cosine function. And again, my A came first in that abbreviation ka, so that number is going to go on top. My H came second, so that number 78 is going to go on the bottom. And then we do a T-chart. Inverse cosine to both sides. Theta equals the inverse cosine of 37 divided by 78. And then I'm just going to punch that into my calculator. Inverse cosine 37 divided by 78 equals. So this one would round to about 62 degrees. That would be this corner right here. All right, now if we flip the page, we do have lots more examples. So this is where I want you to pause, and I want you to try solving these. Actually try doing it, because if you just copy the work, you are not going to be masterful at this. You want to try it, you want to make mistakes, and then check and correct your work. Even though that's more time consuming, it is the only way that you are going to be successful at this. So please give it a pause and then resume to check your work after you've completed it. All right, we're back. I hope you tried all of these questions. Here's my work. I probably should have changed colors in between so you could see them a little bit better. But there you go. All right, so again, make sure that you're actually trying these. You're not going to get any better unless you practice. And then if you're typing in the exact same thing, but you're getting a different result, again, it could be the mode of your calculator. You might need to change that to degrees. Ask your teacher or Google the information for your particular calculator. But there's some practice for you. Okay, now when we flip to the next page, it says, what are the trig inverse ratios? So you can write those down again. Sine inverse, cosine inverse, tan inverse. And if you noticed, all of these, when we're doing those ratios, it's always the inverse of whatever the SOHCAHTOA abbreviation is. So if you want to abbreviate these, you certainly can. Sine inverse of opposite divided by hypotenuse is going to equal your degree. Cosine inverse of adjacent divided by hypotenuse is going to equal your degree. And tangent inverse of opposite over adjacent is going to equal your degree. And then it kind of eliminates the need for a t-chart if you do it this way. But the t-chart's nice because you can set it up the same as you did for the regular sine, cosine, tangent, solving for a missing side, right triangle trig ratios. All right, here's lots of space for you to practice with your homework. Remember, don't try to do it in your head. Make sure that you're writing it down.